Hey guys, welcome back for another little science lesson. We're going to start our new unit on energy. Just make sure you guys are coming to the live streams so that you can get all the notes and stay current on all the events. Energy, the ability to do work. Alright guys, find your note packet and see if you can find this page. It'll be one of the first pages. The ability to do work expresses what energy is all about. It's force times distance. Therefore, energy is related to the force to make something move. So energy is not a real thing that you could measure as far as mass and volume. It's not matter, but it does affect matter, and you can measure energy by how much matter is moved. There are two types of energy we're going to talk about today mostly, and that is kinetic and potential. Let's start with kinetic. Kinetic means motion. The energy of motion is considered kinetic energy. Hammer hitting a nail or anything else you can think of that's in motion, like roller coasters or things falling or skiers or anything at all. Kinetic energy is affected by an object's mass and speed. The greater your mass or speed, the more kinetic energy you have. In this example, the bowling ball has the same cannonball, has the same mass throughout its trip, but its speed is different. At point A, it has great speed, and at point C, it has less speed. So the bowling ball loses kinetic energy as it rises, and then it gains kinetic energy as it falls. The flip side of that coin is potential energy. Energy related to shape or position of an object. By shape, I mean an arrow could be loaded into a bow. As you change the shape by pulling back on the string, you've increased energy stored in the bow, which has the potential to fire the arrow. Also, a book balanced on the edge of the desk has potential energy, more potential than if it was on the floor. Why? Because it has potential to fall. The higher an object is, the more potential energy it will have. This bow has the most potential energy when you draw the string. Note, objects have potential energy even when they're not moving. But with kinetic energy, you absolutely have to have kinetic energy and to be moving to have kinetic energy. So let's remember, as objects move, their kinetic and potential energies are changing. For example, roller coasters, as they go down a hill, kinetic energy increases, but the potential energy decreases as it gets lower. Here's a baseball. As you throw it, potential energy is increasing. It has its maximum potential energy at the top of the curve, and then that potential energy turns into kinetic energy as it falls. If you add your potential to your kinetic, you end up with mechanical energy. This is a combination or sum of all the kinetic and potential energy in the system. A roller coaster has the potential energy and kinetic energy of its mechanical energy. Simply add them together. Here's an example. As you start your roller coaster ride, your speed is low, kinetic energy will therefore be low, but you're also low in position. So you have low energy, but as you go up the hill, your potential energy increases and increases until you're at your maximum potential energy. As you start to go down the hill, that energy is converted into kinetic energy until you're at your maximum speed, but lowest potential. In your packet, try to label each of these as either potential or kinetic, and you can argue for different answers depending on what you're seeing in those pictures. Go ahead, pause the video, take a look, and see what you get. The drawn bow is a great example of potential energy. An arrow after hitting the target is not moving. It's not moving after it hits the target. That's potential energy. Now, an arrow just before hitting its target has a huge amount of kinetic energy. But remember, you have to be in motion to have kinetic energy. Here's one, crashing through the wall. Now that is definitely showing quite a bit of kinetic energy. The raised wrecking ball is not moving, but it has a lot of potential energy. A stretched rubber band has plenty of potential energy. As it flies through the air, it has kinetic. As it comes to rest on the table, no movement means no kinetic energy. Back to potential. Running lawnmower, of course, all those moving parts are kinetic. All right, guys, let's take a quick look at an upcoming project, which will be about energy in the news. Your homework is to read 2 articles about energy in the news. There's a folder in Schoology with a website called Science News for Students, which is going to give you some very reliable information. I want you to find 2 articles about 2 different kinds of energy. Then you're going to be comparing and contrasting in your project. For now, though, I just need you to find some articles that you like, that are interesting in Science News for Students, and see if you can find a couple different kinds of energy. Maybe you're interested in electricity or electric cars. Maybe you're interested in windsurfing and you want to talk about the energy in the wind. Maybe you're interested in talking about frictionless parts in a motor and you want to learn how that happens, or how climate change is affected by different kinds of energy production that humans make. Whatever it is, make sure it's a semi-current article, and you're going to want to find 2 of them that you eventually can compare similarities and differences. All right, guys. Appreciate you tuning in. Thanks so much for trying science. See you on the next one. Bye. Bye for now.